Hi, this is Akshay Gole, and today we are going to find out how to find the range of a projectile along an inclined plane. And this question was asked by our viewer, Mr. Arnav. So let us find out. So the question is, a particle is projected with a speed of v naught at an angle theta to the horizontal on an inclined surface making an angle phi, where phi is less than theta to the horizontal. Find the range of a projectile along an inclined plane. So let us try to visualize this question. Consider this is that inclined plane which is inclined at an angle of phi with a horizontal. Let us consider that the projectile is projected in this direction with angle of projection theta, and this is the trajectory of projectile. Right. So the range of a projectile on an inclined plane is r. So x component of r is r cos of theta and y component of r is r sin of theta. Therefore, we can put y is equal to r sin of phi and x is equal to r cos of phi in the equation of trajectory. So we know the equation of trajectory, that is y is equal to tan of theta into x minus g upon 2 u square cos square theta into x square. So let's put this value. We get r sin of phi is equal to tan of theta r cos of phi minus g upon 2 u square cos square theta into r cos of phi square. So we can say that this one is equal to r sin of phi is equal to tan of theta r cos of phi minus g upon 2 u square cos square theta into r square into cos square of phi. Let us take r common from right hand side. What we'll get? So taking r common from RHS, we get r sin of theta, r sin of phi is equal to r into bracket tan of theta cos of phi minus g upon 2 u square cos square theta into r into cos square of phi. So these two r gets cancelled. So this r and this r gets cancelled out. So we get sine of phi is equal to tan of theta into cos of phi minus g upon 2 u square cos square theta into r cos square of phi. Now, as we are interested in this value of r, let us take it in right hand side. So g upon 2 u square cos square theta multiplied by r cos square of phi is equal to tan of theta cos of phi minus sine of phi. So therefore we get r is equal to 2 u square upon g into cos square theta upon cos square phi multiplied by tan of theta into cos of phi minus sine of phi. Right. So what we get? We had the value of r which is equal to 2 u square upon g into cos square theta upon cos square phi multiplied by tan of theta can be written as sine theta upon cos theta into cos of phi minus sine of phi. So let us take this cos of theta inside this bracket. So what we get? We get r is equal to 2 u square upon g into cos of theta upon cos square of phi multiplied by cos of theta into sin theta upon cos theta into cos of phi minus cos of theta into sin of phi. So here this cos of theta and this cos of theta gets cancelled out and we get the equation as we get the equation as r is equal to 2 u square upon g into cos theta upon cos square phi multiplied by sin theta cos phi minus cos theta into sin of phi. We know that sin theta cos phi minus cos theta sin phi can be written as sin of theta minus phi. So the answer of this question or the range of the projectile on an inclined plane can be given as r is equal to 2u square upon g into cos of theta upon cos square of phi multiplied by sine of theta minus phi. I hope you like this video. If you like, don't forget to like, comment, follow or subscribe our channel. See you next time. Thank you very much.